Example 4. So here they're giving us the choice between side angle side or side side side. We have to choose. So what I'm going to do is kind of make little notes here. I got side. Oops. I'll switch my pen color there. I got side, 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 and side angle side. So I'm going to look through the information that they give me and see which of these match up well, right? So I'm given BC is congruent to DC. So BC congruent to DC. Okay, that gives me a side. That works for both of them. Ooh, here it gives me an angle. BCF is congruent to DCE. All right. So far it's looking like I've got myself some angle information. And the last piece here is FC is congruent to EC. Oh, look at that. I got another pair of sides there. So I should have enough to do side angle side. The only thing I have to worry about is, do we have the correct pieces for the triangles we're talking about? But so far it looks like side angle side is the way we want to go. So what we're going to do is we're going to highlight. And when you're doing this on your paper, I highlight all the time because I can erase it really easy. But just kind of lightly with your pencil, kind of sketch out on top of the drawing, okay, these are the two shapes that I'm going for. C, F, D. Ooh, uh-oh. That triangle. Well, I can definitely see I got the two sides there. And the other one is CEB, CEB. Well, I definitely got the two sides there. So it's somehow I just have to show either that angle in the middle works or um, the something about the third side. Well, I know nothing about the third side, so I'm still thinking side angle side. That's still what I'm going for, right? I still think that's the way to go. Um, if I take a look here, excuse me, I don't know why I'm coughing. I've probably been talking too much. All right, let me break out these triangles here separately. B, E, C, and then I have C, F, D. So I can see here I got BC and CD are congruent, and I got FC and EC are congruent. So if I could find out something about that angle C at the bottom, if I could somehow show that that angle is congruent, then I would have side angle side. Well, what do I know about that angle? Let me try to investigate a little bit. Well, I've got this part of it and this part of it are congruent, but what I'm really looking for is that this whole angle here is congruent to this angle here. Well, wait a second. They have that shared space in the middle. I'll highlight it in pink. They've got that shared angle in the middle there. Well, it's always going to be congruent to itself, right? So there's what it is. I'm going to set up something about those two angles adding up to the same thing. So like think of it angles 1, 2, and 3. If I can show that angle 1 and angle 2 are going to add up to be angle 2 and angle 3, then it works. And I should be able to, because I already know 1 and 3 are congruent, and 2 always has to be congruent to itself. There we go. Now I've got everything I need. So, statements. Reasons. So, BC is congruent to DC. Those are segments. Angle BCF is congruent to angle DCE. And FC, let's try that again. FC is congruent to EC. Those are given. All right. Now I want those that those bigger angles there that I kind of highlighted in blue to be congruent to each other. So, but I don't, like before I kept jumping down straight to that. I'm going to have to do a little bit of work to show it this time, right? And the whole thing depended upon this angle 2 being congruent to itself. So let's start with that. What is that? That's angle FCE is congruent to angle FCE. That's reflexive property. So reflexive property. It's always congruent to itself. Now with that, I should know that the big angle that I want, angle BCE, right? This green angle that I had right down here should equal FCE, that angle in the middle, plus measure of BCF. Sorry, it's kind of tight there. I'll try to write a little bit more space. And that is the angle addition postulate. And I also know that angle BCE should be equal to the measure of angle FCE and measure of angle DCE. Again, that's angle addition postulate. Well, I also know that BCF and DCE are congruent because that was one of our givens. So I can replace one with the other. Measure of angle BCE is equal to measure of, well, no, if I just plug that in, I just get that same line again. Oh, wait a second. Can I subtract measure of angle FCE from both sides? Measure of angle BCE minus measure of angle FCE is equal to the measure of angle BCF. Measure of angle. And if that's true, I've just shown, I'll circle it in yellow, that I can substitute it in, that substitution there itself, or I guess it would be subtraction, right? Subtraction. But those two things are equal, so I can substitute them in. Oh, that's where my mistake was. So my problem was I wrote the same expression down for both of these things, but they're not the same, right? BCE is on the left triangle. DCF is on the right triangle. So this one of these here DCF. I'll highlight it in yellow to show you my mistake there. I wrote down the wrong angle. Alright. Keep going, but now I can do the substitution that I wanted to do. Because BCF is congruent to DCE, substitute that in, measure of angle BCE equals measure of angle FCE plus, and this is where the substitution comes in, measure of angle, oh shoot, I did it again, DCF, measure of angle BCE minus measure of angle FCE And you can see the FCEs are going to cancel out. We got ourselves measure of angle DCF is equal to measure of angle BCE. And if the measures are equal, then the angles are equal or congruent. BCE, definition of congruence. And now I've got my side angle side, so I can say the two triangles are congruent. Let me just put the names in the right order. So angle or triangle CFD is congruent to triangle CEB. By side angle side. Alright, a little bit of extra work there. And these steps I didn't necessarily show the justify, but it's just substitution. And then here it's substitution again. Simplifying is the same as substitution. I'm not so worried about showing that you did substitution or subtraction even, but that you've got those ideas down there. That one was a little bit harder.